We're going to continue our unit on statistics with normal distribution. Data can be distributed or spread out in different ways. It can be spread out more on the left. In this particular picture, the higher bars are on the right, but this is more spread out. Okay, so this would be considered spread out on the left. Or it can be spread out on the right. See how it's more spread out? The lower bars are in this on the right. Or it can be all jumbled up. But there are many cases where the data tends to be around a central value with no bias left or right, and it gets close to a normal distribution like this. This is also called the bell curve. Lots of things in the real world fall on the bell curve. People's height, people's weight, people's IQs. Lots of people fall into this curve. Okay? Really, really tall people would be on this part of the curve. That's not the majority of the population. Okay, not many people are above 7 feet tall, so that would be over here. Super, super short people would be over here. Most of us are in the middle, in this middle chunk. This is where most of the population would fall for height. The breakdown of the bell curve. The total area under the curve is 100%. 68% of the value will lie within one standard deviation of the mean. 95% will fall between two standard deviations of the mean. 99.7% of the values will be within three standard deviations. This is called the 68, 95, 99.7 rule. That's also called the empirical rule. Okay, it says to determine the probability that a single data point will fall within a given range of possibilities. Alright, this is a standard bell curve, what it would look like. Okay. When we break this down into those percentages we just talked about, 68% would fall within one standard deviation. Standard deviation means this is the middle. One standard deviation would be one line over. So this is the mean. Okay, and these blue lines would be one standard deviation. So 68% total would fall between these blue lines. So that means between the first blue line and the red line would be half of that, 34%, and then 34%. So total 68% would be between blue line and blue line. Okay? Then it says that 95% would be within two standard deviations. So if we drew another line down here, that would be our second standard deviation, our second line away from the mean. So 95% of our data would fall between here. So from here all the way over to here would be 95%. So if you take 95% minus the 68 that we already put in our curve, if you subtract that, you would get 27. And then divide that by 2, that would leave 13.5% would be in this area of the curve, and 13.5% would be in this area of the curve. Alright, then it says that 99.7% is within three standard deviations, so that would be this little line. So from the little red line all the way over to the little red line over here would be 99.7%. So if you took 99.7 and subtracted the 95 that we've already included in the curve and divided that by 2, this little part in here would only be 2.35% of your population or curve, and 2.35%. So if I took 99.7% and subtracted that from 100, this itty bitty gap that you can barely see here at the edge would only be 0.15% of the curve, and this little bitty edge right here would only be 0.15% of the curve. So when you look at a standard bell curve, a normal distribution, it'll be 0.15%, 2.35%, 13.5%, 34%, then 34%, 13.5%, 2.35%, and 0.15%. Okay, a standard deviation shows how much variation or dispersion from the average exists. So when we talk about average, okay, we're talking about the mean. A low standard deviation indicates that the data points tend to be very close to the mean. A high standard deviation indicates that the data points are spread out. So if a standard deviation, the bigger number of standard deviation is, the more spread out the data is. The smaller standard deviation is, the closer the data is together. So a test was given to 300 students. The mean score is 75%. So that is this middle line would be 75%. Okay, with a standard deviation of 10 points. So if you did a standard deviation, okay, that would be 1 standard deviation, 2 standard deviations, 3 standard deviations. That's normally what it looks like. 1 standard deviation, 2 standard deviations, 3 standard deviations. And we're saying that the standard deviations are 10 points. So each line would go up by 10. So 75, 85, 95, 105. Then to go backwards, it would be 75, 65, 55, 45. So those are the test scores. Okay, when you draw a bell curve and you put in your percentages, it's always, these are 34. That's always true. And then 13.5, 13.5, 2.35, 2.35, and this itty bitty gap here is 0.15. The itty bitty thing here is 0.15. That would be filling in the bell curve, and those are always the percentages. The only thing that we changed in this example were the numbers at the bottom. Those were the test scores, 45 through 105. Okay, using that bell curve that's already filled in here, you need to use the one that you just filled in. Okay, it says A, what percentage of students fall between 65 and 85%? Okay, so 65 is this line, 85 is this line. So what is the percentage between 65 and 85? Well, the percentages there are 34 and 34. So if you add those percentages together, the percentage of students between 65 and 85 for scores, 68% of kids scored between a 65 and an 85 on the quiz. B, what percentage of students fell between 55, that's this line, and 95, this line? That would be all of these percentages. So if you added up 13.5 plus 34 plus 34 plus 13.5, that means that 95% of the kids that took this quiz scored a 55 to a 95. What percentage of students fell between 65 and 75? Between 65 and 75, 34% of the kids that took the quiz scored a 65 to a 75. What percentage of students fell between 75 and 105? Okay, so that would be 34, 13.5, and 2.35. Those are the percentages between 75 and 105. Okay, if you added all those up, you would get 49.85% of students that took this quiz scored in that range. Alright, how many students, not the percentage, but how many students scored between a 65 and an 85? So we know those together is 68%. So 68% of the kids scored in that range. But we want to know the number of kids. There were 300 total times 68%, which in a decimal is 0.68. If you put that in your calculator, 300 students total times 68% is 204 kids. 204 kids scored on their test a 65 to an 85. How many scored between 55 and 95? So again, we added these up already. When you add them up, you would get 95%. So there were 300 total students times 95% would give us our total number of kids in that range, which was 285. 285 students got between a 55 and a 95 on the quiz. How many students scored between 65 and 75? That was only 34%. So there's 300 kids, 34%. 300 times 34% would give us 102 kids. 102 students scored between a 65 and a 75 on the quiz. And how many students scored between a 75 and a 105? So if you added these percentages up, which we already did, that would be 49.85%. Okay? There was a total of 300 students. If you multiply that by the percentage, that would be 0.4985 in a decimal. If you put that in your calculator, you would get 149.55 kids. Okay, if we're talking about kids, you would probably want to round that up to about 150. About 150 kids scored between a 75 and 105 on the quiz.